All right, hi guys. So today we are going to cover using square root and cube root functions in like real life scenarios. So our first example here says the rotor in an amusement park ride that was designed in the late 1940s, riders stand against a circular wall. When the ride reaches a certain speed, the floor drops and the centrifugal force keeps the rider pinned to the wall. The function that models the speed necessary to keep someone pinned to the wall is given by S of r here, where r is the radius in meters of the rotor. So what is the feasible domain of the function and what is the feasible range? Well, remember that the domain are all of the possible input values for a certain function, right? And the range of a function is all of the possible output values of a function. Now, what are the possible input values? Well, not taking into consideration the real world problem, any square root function, if it doesn't have any transformations, is at 0, 0. Starts at 0, 0, cannot have any negative values of x or negative values of y. Now, looking at the scenario here, that also makes sense because the input is r, which is radius, which is a measure of length. So how can we have a negative measure of length? That just doesn't matter. So even more to the explanation that the feasible domain here would be only possible values. You could technically not have anything, right? Or you can have positive values of radius. Now, for the output, right, S of r, this is what tells you the speed, right? The speed necessary is this equation here. So S of r is the output, and that represents the speed. Another one where, again, if we think about it, we can't have negative values. We cannot be moving at all. We could have a speed of 0, but we can't have a negative speed. Okay. Now let's take a look at the sketching of the graph. That's what they want us to do next. We want to sketch the graph. Now, remember that for the square root function, right, the y equals square root of x, we have an extrema point, and then the graph goes up and to the right. Okay, so that is the picture that I should expect, since this is really just multiplying 4.95 to the input, which means that you are affecting the x-axis, right? Technically, this input x is really r, and the output y is really S of r. So that extrema will stay at the same point because we didn't shift. If you look at this function here, it's not shifted left or right at all. So the extrema will be at 0, 0. And what I'll do is I can use, multiply 4.95, the reciprocal of that to the inputs, but I'm going to do something that's a lot easier. I know that it's not reflected at all. Like if it was reflected over the y-axis, then it would actually be pointing into to the left. If it was reflected over x, it would be either pointing down. If it was reflected over both x and y, then it would be facing this direction. So since that is not the case, and there are no reflections, it is going to point up and to the right. So I just need to figure out exactly how far up and to the right. So I already know that 0, 0 is a point, and of course I could check that by plugging in S of 0 and simplifying. So 4.95 times 0 would be 0, and then the square root of 0 would give me 0. So I check, yes, 0, 0 is a point. Now, the next thing that I'm going to do is plug in some other points. Let's go ahead and plug in 2 and 6. So I'm going to find S of 2 first. So I'm going to plug in 2. So 4.95 times 2. And I'm taking the square root of that. Now, I'm just going to use my calculator for this. So I'm going to go ahead and plug in square root of 4.95 times 2. And that is about 3.1. So the point 2, 3.1 is on the graph. I think 3 points will be good enough for a sketch, so I'm going to go ahead and plug in one more point. I'm going to pick one a little bit further away. We can go with 6 or 8. I'm going to go with 8, actually. So let's find S of 8, which would be found by doing square root of 4.95 times 8. And let's go ahead and, again, use our calculator for that. So square root, I'm actually just going to go here and replace the 2 with an 8 and hit enter. So that's about 6.3. So the point, input 8, output was 6.3, is on the graph. So let's go ahead and plot both of those. I actually forgot to plot 2 and 3.1. So just a little bit higher than 3. And then 8 and 6.3. So a little bit more than 6. Okay, so that's our graph, and then we could just connect the dots. We know that this is going up and to the right, so there you go. That's the graph for our function. Now, the bottom question says, what is the necessary speed? So they're asking us, what is S of R? What is the output? Okay, what is the output? To keep a person pinned to the wall on a rotor that has a 9-meter radius, okay? So remember, R is the radius in meters. So basically they're saying, what is the output when the radius is 9? So we're finding S of 9, okay? And we were 1 away from there. It should be a little bit bigger than 6.3. So let's check the square root of 4.95 times 9, and we'll go ahead and round that when we figure out what it is. So let's go ahead and plug it in, and again I'm just going to go back to my calculator here and enter that so I can just change 8 to 9, and we got 6.7. So the necessary speed to keep a person pinned to the wall is 6.7. And I'm looking for any measure of speed, and I don't see one in the problem. It just said speed. It doesn't really say the unit of measure, so it's good enough, 6.7. All right. Let's move on to the next example, and I will let you pause this video now and try this problem on your own. All right, so this question says the shoulder height, and this is measured in centimeters, of a male African elephant can be modeled by the function h of t equals 62.5 cube root of t plus 75.8, where t is the age of the elephant, and that is measured in years. So the shoulder height can be modeled by this function. So the shoulder height is h of t. Shoulder height is h of t. And the age is t. Now, the first parts, A and B, ask for the domain and the range. Now, what is the input? It's t, right? So the input is t, and that input is age. So the age can only be positive. So the age is anywhere from 0 to, in theory, infinity. there is probably a max, age that any elephant has ever lived to, but, that's getting more precise. In theory, we'll just say from 0 is the lowest. Definitely negative values can't be, right? Now, what about the range, right? For the range, we're looking at the possible Y values, right? The possible H of T values. And that is the shoulder height. Now again, with shoulder height for an elephant, that can't be negative. But there's also, when they are born, there is a particular value, right, that their shoulder height would be minimum. So one way that we can find that minimum shoulder height is to find the height at birth, right? When you are just born at 0 ages, right? You just brand new, spanking new born. What is your shoulder height? So we'll find H of 0. So 62.5 cube root of 0 plus 75.8. Now, the cube root of 0 would just be 0. 0 times then 62.5 would be 0. 0 plus 75.8 would be 75.8. So the shoulder height, the minimum shoulder height of an elephant, right as they're born, is 75.8. And of course, their shoulder height would then continue and get larger from there. Now, let's go ahead and sketch this graph. Now, what kind of function is this? This is the cube root function, right? Now remember, the parent function for the cube root function looks like this. You have a center, and then you have going like up and to the right. You start from the bottom, and then you go up and to the right. That's the look of it. And of course, the center for the parent function is at 0, 0. Now, this graph here, if you notice, it is shifting not horizontally, but it is shifted vertically, okay? So there is no reflection because there are no negatives, but it is shifted vertically up. So that means that this center that was initially at 0, 0, that would be shifted up. Now that's not going to affect the X value, right? The X value will still be 0, but the Y value will be shifted up. So that Y value is 75.8. We can also see that from H of 0 is 75.8. Now normally, right, we would have these negative values of X, but based on the real world problem for this function, we can have negative age. So you will see this left side of the graph not show up because it just doesn't make sense to show up here for this real world problem. So the first point, when you are just born, your output, your shoulder height is 75.8. Now I have to label this, so I'm going to go ahead and label the x-axis is age and the y-axis is shoulder height. And now I have to figure out how do I want to go up by. Actually, you know what? I'll find some values and then I will, figure out what I want to go up by later. So you can now pick any random x value in to plug in to the function to find the output. So I'm going to have to take the cube root of that input. So I'm going to go with, let's go with, for the first cube root would be 1. And then let's go with 8. And let's do one more. Let's go with, I believe 81 is the next perfect cube. So let's go ahead and plug those in. So we need to find h of 1. We need to find h of 8. and we need to find h of 81. And I'm just going to use my calculator for this. So remember, h of t is 62.5, and then we need to take the times the cube root of our first t value is 1, and then plus 75.8. Enter. 138.3. Okay, let's do the next one. And again, like I showed you guys, I'm just going to go up to that line, hit enter, and then I can edit. I'm going to go scroll over to the input that I put is 1. My next input that I want to put in is 8, and then I can hit enter. So that one is 200.8. And then lastly, I need to input 81. So instead of t being 8, I need t to be 81. And then hit enter. All right, so we got 346.2. Okay, so when x is 1, y is 138.3. When x is 8, y is 200.8. And when x is 81, y is 346.2. Okay, and actually, because I used my calculator, I didn't really need to use perfect cubes because I used the calculator anyway. So, yeah, I'm not going to graph age of 81, so that was silly for me to even do that one. I would have probably wanted to pick maybe 10. That way I had a fourth point. But I'm just going to go ahead and graph these three. So I have 0 to 8. So if I label this by ones, I just want to make sure that I will get to 8, 5, 6, 7, 8. Perfect. 9, 10. And then on the y-axis, I have to go all the way up to at least 200. So if I go up by 20s, does that work? 20, 40, 60, 80, 100, 120, 140, 160, 180, and 200. Yeah, perfect. So now I can go ahead and plot my points. So we have 0 and 75.8, so halfway between 60 and 80 is 70, so 75 will be like around there. 1 and 138.3, so that's just a little lower than 140. And 8 and 200.8, so that's just right above 200. Okay, and then now I can go ahead and connect my dots. Wonderful. Let's move on to the last part, part D. Find the difference of the shoulder height of a 10-year-old elephant and a 5-year-old elephant. Okay, once again, we were so close to having one of these values already. We picked 8, but so the 10-year-old elephant will have a shoulder height that is obviously bigger than 200, and the 5-year-old elephant would have a shoulder height that is smaller than 200. Well, we have to figure out what they are. So first, let's go ahead and find the 10-year-old elephant's shoulder height. So I need to find h of 10. And of course, I'm just going to put this in my calculator, but what I will be putting in my calculator is our function, 62.5, and then times the cube root of the input, which is 10, plus 75.8. And then I will need to do the same thing, except for a 5-year-old elephant. So the age here will be 5. And again, I'll just put it into my function for the shoulder height of an elephant, which is 62.5 times the cube root of 5 plus 75.8. Okay, so let's use our calculator. And I already have plugged all that stuff in, so I'm going to hit enter, and I'm going to replace 81 with, I'm going to delete the 1. Actually, I didn't need to do that because it's 10. So 1, 0 is 210.5. And plugging in a shoulder height of 5. Now I'll need to delete that second digit because 5 is only 1 digit long. And that is about 182.7. All right. So now we can actually find the difference of the shoulder heights. We have the shoulder height of a 10-year-old elephant, which I will change to blue because just color coordination. The height of a 10-year-old elephant is 210.5 about. The height of a 5-year-old elephant is 182.7. And so then the difference, and again, I'm just going to be a little lazy using my calculator. So we need 210.5 minus 182.7 is 27.8. And the shoulder height is measured in, let's go back up, I already forgot, centimeters. So the difference of a shoulder height of a 5-year-old elephant versus a 10-year-old elephant is 27.8 centimeters. Great. Doesn't really sound that large, actually. All right. So let's go ahead and move on to another question. Now, I'm going to do this one with you, and then I have a couple of challenge problems for you to try on your own. Okay. So consider the following function, and they gave us a function. So this is a cube root function. Again, remember, the original parent cube root function, right? You have your center, and then you go from down, up, and to the right, okay? And that center is originally at 0, 0. Now, look at this function. First, it's shifted to the right 2 units, and it's shifted up 1 unit. So that means that if you're shifting the center to the right and up, right, that new center is at 2, 1. Now, another thing that happens is that it is being reflected. You're changing the sign on the outside. So you're changing the sign of the Y, which means you're going to reflect over the X-axis. So imagine if we had an X-axis here per se, right? And I reflected over that, now this bottom part will actually be up, and this top part will actually be on the bottom. So instead of going from the bottom and up, you're going from the top to the bottom. So in other words, this new function, without me having to graph it, just a rough sketch, right, will look something like this, okay? Where the center is at 2, 1, because I went over it with my line here, okay? So your center is at 2, 1, and then it is reflected over the x-axis, so that is the general shape. So it asks, which of the following statements are true? Select all that apply. The graph is a cube root function. Well, that's easy. Yeah, it is. Okay. The domain of the function is from 2 to infinity. No. Arrow on the left, arrow on the right, all real numbers. So the domain should be negative infinity to positive infinity, so that's incorrect. The range of the function is negative infinity to positive infinity. Yep, arrow on the bottom. Now, again, you know, it looks like it's flat, but it's not flat. If you zoom in closer and closer, you will see that that is slightly getting larger and larger on the left, and on the bottom, this is just slowly going to continue to go down. Very slow, but it does. So the range is from negative infinity to positive infinity. That is correct as well. The graph has an X-intercept at 3, 0. Interesting. Well, I don't know what the X-intercept is, so let's find it. Remember to find the X-intercept. We set Y to equal 0, and we solve for X. So let's do that. Let's say Y to equal 0, and I'm going to go ahead and solve for the X value. Okay, in order to solve this, I'm going to first have to get this cube root to be by itself, so I will subtract 1 on both sides. So I get -1 equals negative cube root of x minus 2. And then I will need to divide by -1 to get rid of that -1 coefficient. So I end up with 1 equals the cube root of x minus 2. Then I have to get rid of the cube root, so I will go ahead and cube both sides. 1 cubed is just 1, so I end up with x minus 2. And lastly, I need to get rid of the minus 2, so I will add 2 on both sides, so I end up with 3 equals x. So when the y value is 0, the x value is 3, so that is our x-intercept, and therefore this is in fact correct. All right, let's look at the next one. Now the next one says the graph has a y-intercept at 0, 1. Well, if your y value at 1, you know, is already at 2, the y-intercept can't be there because you're not going to have, you know, 2 places where the y value is the same for a cube root function. That's just visually, you could see that that's impossible. However, let's say you wanted to figure it out algebraically, right? Let's find the y-intercept. Okay, let's do it. Well, the y-intercept is setting x to equal 0 and solving for y. So let's go ahead and do that. Y equals negative cube root of 0 minus 2 plus 1. Now, 0 minus 2 is -2. Negative cube root of -2. First, the cube root of 2 is not anything special. Well, let's go ahead and bring out the negative, right? Oops, I forgot to bring down plus 1. If we bring out the negative, because the cube root of -1, if I break the cube root of -2, if I break that up into the cube root of -1 times 2, then I can split up this into the cube root of -1 times the cube root of +2. You always want to bring out the negative. So that will be -1. So we have -1 times, this is the -1 from here, then the -1 from here, and then times the cube root of 2 that remains. Now, -1 times -1 is +1, and +1 times the cube root of 2 would just be the cube root of 2, and the cube root of 2 plus 1 is not a whole number. It's definitely not a whole number, and it's definitely not going to be 1. So, no, this is not correct. All right, last one says the graph is decreasing all the way from left to right. Remember, decreasing just means that the y value is getting smaller and smaller, right? So looking at the y value, right, and if I follow along with my pen, I do see this going down. Even here, where it's like this, right, where it's the top part, it's still getting smaller. So it is decreasing to the left of the center. And then to the right of the center, you could see that it is also continuing to go down. So this is correct. It does go down the entire time. All right. So go ahead and pause this video now and try the beat the test on your own. Okay, so for number 1, it says, which of the following functions matches this function? So let's see. Well, this first is a cube root function, right? Let's see if we can narrow it down. No, all of these are cube root, so okay. Next up, you see the center is right here. So the center is at -2, -4. Okay, now remember, with x is always the opposite, so on the inside I would actually need to see it as +2. Okay, so these 2 are correct, these 2 are incorrect. And then the y value is exactly as I see it, so this is -4, so +4 would be incorrect. So it's B. That one was easy. All right, let's move on to number 2. Okay. So consider the following function. Which of the following statements are true? Select all that apply. The graph is a cube root function. Now that is incorrect looking at this function, do you see it is the square root? Now, actually, before I continue to read those, let's talk about this function. So it's a square root function, right? Now remember, the original function, the original square root function, the parent function, has an extrema point, and then that graph goes up and to the right. Okay? Now, this function has a shift. You're shifting right 2 units, and you're shifting up 3 units. So the center was originally at 0, 0. Now the center is at 2, 3. Okay? Not only that, but it is reflected over the x-axis. How do I know that it's reflected over the x-axis? Well, because it's changing the sign of the y value, right? You're changing the sign on the outside, which means you're changing the sign of the y value. So again, and I'm just going to move this point over so I don't mess it up when I go to graph my line. If you imagine, here's the x-axis. If I reflect this graph over that x-axis, right, that horizontal line, then I will actually be pointing down and to the right. So this graph here will actually be pointing this way. Okay, now again, I'm not really graphing it on a coordinate plane. I'm just doing a rough sketch so that I can answer these questions. Okay, now it says that the domain of the function is from 2 to infinity. Now, what is the x value here? The x value is 2. So yes, the smallest x value will be 2, which is the extrema point, and then we will go all the way up to infinity. That is correct. Next, they're asking us the range of the function is from 3 to infinity. Now, that's not right. The highest value is actually 3. The lowest y value is in negative infinity, right? So the range would actually be negative infinity till 3. So that is incorrect. Next, let's look at x and y-intercept. Again, to find the x-intercept, we're going to go ahead and set y to be 0 and solve for x. So I will go ahead and solve this function. So first, I will need to subtract 3 to get rid of that 3. And then I can go ahead and divide because there's a negative 1 that's multiplying to the square root of x minus 2. So I could go ahead and divide by negative 1 on both sides. So I end up with 3 equals the square root of x minus 2. And then I want to get rid of the square root, so I'm going to go ahead and square both sides. 3 squared is 9. Actually, we got rid of the square root, so now we have 9 equals x minus 2. And then lastly, I got to get rid of the minus 2, so I will add 2 on both sides. So I end up with x equals 11. So when the y value is 0, the x value is 11, and therefore this is in fact correct. All right, now let's do the same thing. Actually, not the same thing, but let's find the y-intercept. So for the y-intercept, I set x to be 0 and solve for y. Okay, so I have 0 minus 2, which is negative 2. So I have y equals negative square root of negative 2 plus 3. And I can't simplify the square root of 2, but I can simplify the square root of negative 1, which is I. So this will be negative from the outside, and then the square root of negative 2 is the square root of 2i. And of course, plus 3 is plus 3. Now, this is an imaginary number. It's definitely not a real number, even less a whole number of 3. So this is incorrect. And then lastly, the graph is decreasing. Again, looking at the graph, is it going down the entire time? Yes. So that is in fact correct. All right, guys. So I hope that that was a helpful video for you, and I will see you guys in the next one. Bye.